I want to dig a little deeper as to what's really going on behind the scenes when you run this loop. And for that, we can use something called the debugger. And pretty much all IDEs have this ability to step through the code line by line, and you can visually see what's going on, what values are being assigned to the variables, and basically see the program flow. So let's try that. So let me get rid of this line here, just to clear things up. I'm going to create a new variable, and I'll just call it counter or something. And I'll give it the initial value of 0. And inside of this loop, I'm going to say counter is equal to counter plus 1. And this, of course, is essentially the same thing as if I was to create a temp variable here and assign that to that, and then assign temp to the counter. It would essentially be the same thing, right? So just so we have more lines to see and more lines to step through and understand how the debugger works, I wanted to add this extra stuff here. It is somewhat extraneous. I could just do counter plus plus, but I created this temp variable so you can see what happens and how it gets assigned and so on. And another thing I want to do here is change this to what we're used to seeing, which is I plus plus. This again is the same thing as I is equal to I plus 1. Okay, so you can actually just leave that there. Now we need a breakpoint, and what the breakpoint is basically when you kick off the debugger, as soon as it sees the breakpoint, it will pause the program execution, and I'm going to set the breakpoint here right on this line. And all you have to do is go to the left of these numbers, depending on if you have the line numbers turned on or not. Just go to the left here in this gray bar and double click, and that will create a breakpoint. So you can right click and go to debug as Java application, and that will kick off the debugging process. So let's click on that, and notice it launched this new perspective, and the program has kicked off, and it's waiting for us to basically step through it. Okay, it's paused at the breakpoint that we set right there. Right, this green highlighting is basically making it pause there. That's what it's showing. So now we can step through the code. So click on this button called Step Over, and notice that counter is initialized. Okay, this is the value of counter. It's currently set to 0. Step over again, and we're about to enter the loop. All right, at this stage, this line has not executed yet. Think of this as sort of waiting right in the beginning of the line to execute this line. So the I variable has not been assigned, this condition has not been set, and this happens at the end of the loop, and you'll see what I'm talking about here. So let's step through, and we have entered the loop. Notice that we have another variable appear here, the I variable, and it's being initialized to 0. So just step through here. We print the I down here, the value of it, that's a 0, and hit step through again, and notice we have a new variable that popped up called the temp, and its value is 1, because remember we are adding 1 to the existing value of counter, whatever that is, and at this point it was 0. Okay, and if you hover your mouse here, it's still 0. All right, we haven't changed the value of counter, we just assigned it plus 1 to this temp variable. Now we are about to change the value of counter. As soon as I click on this step over button, it's going to assign temp to counter, and you'll see this counter value change here. Right now it's a 0. So let's step over and watch what happens. There you go. Counter is now changed. Temp is gone because we are in a new iteration. The I variable still exists. That's part of the loop. And the counter still exists because we've basically assigned that out here, but temp has pretty much disappeared. That was within the scope of that particular loop iteration. Okay, that iteration is over. We're about to move to the next iteration. If I hit this step over button again, I will be actually incremented by this instruction here. I is equal to I plus 1 is going to get run. So understand that the incrementing of I happens right at the end of a particular iteration, right? As soon as that particular iteration is about to be over, the I's value is advanced. But you don't really see that in the debugger. the debugger only recognizes executions, the next particular execution. And when that happens, that's when it will show the updated value of I. Because remember, this line has not run yet. Basically, the debugger is waiting right at the beginning of this line here until we hit the step over button. That's when it will recognize the changed value of I. So step over again, and we initialize the variable temp and assign it the value of counter plus 1, whatever the value of counter was at the time. And that was 1. In the second iteration, we add a 1 to it, and then the temp value is 2. We assign 2 back to counter. Step over, and now we are about to enter the third iteration. So hit the step over button again, and notice I has been changed to 2. So keep stepping through this, and you can play around with this, and notice the values on the top right corner here. Keep an eye there. Notice how they are changing as we are stepping through this code, and this is going to run all the way up to 100. Okay, until I is 100, this loop is going to continue to run. And finally, when it's 100, when I is equal to 100, this loop will run one last time. So to basically execute the rest of this program, you could just hit this play button, this run button here, and that will basically let it execute the rest of the program, and it won't wait for us to click on the step over button until it come across as another breakpoint. Alright, so hopefully this gave you a good overview as to what's going on behind the scenes when your code is running. Using the debugger can help tremendously in figuring out what's going on in a program. And definitely use this tool. It's available to you to solve some of the puzzles in the course. So I want to continue to talk about loops. There's a lot you can do with these. So I've stopped the debugging environment, and I've sort of cleared up the screen here to make some room for new concepts. So let's create a loop, and I will say that we'll initialize a variable called idx is equal to 0. That's going to be its initial value. And as long as idx is less than 100, this loop will continue to run. And we eventually want this loop to end, so we'll increment idx by 1 every iteration. All right, so this is your plain loop. Now I can do a sysout here and print the value of idx. And of course, let's hit the play button, and that goes all the way up to 99, all right? From 0 all the way up to 99. Now inside of here, we can put if statements, we can put all kinds of code, we can invoke other methods, as well as we can put another loop inside of here. So let's do that. I'll create another loop, and we'll initialize a variable called j. And as long as j is less than 10, this loop will continue to run. And every iteration of this nested loop, we're going to increment j by 1. And inside of here, we can have a print line statement that will print the value of this variable idx from the outer loop. So we can say the value of idx was, and then I can just put a plus sign there and just use this variable here from the outside loop. Now, can you figure out what's going to happen when I run this program? Let's hit the run button. Right, notice what it did. It printed out the index value 99 10 times, and if you scroll up, it did the same thing for 98, the same thing for 97, 96, all the way up to, from 0 to 99. For every one of those numbers, it printed this sentence 10 times. Now I can print the value of j here right inside of this print statement. Let me do this, and I'll just put something like that, and then we can show the value of j as well. So let's hit the play button again, and notice that since this loop runs from 0 all the way down to 9, right? That's what, according to this line here, that's what it's supposed to do. The value of j changes every iteration, and it's incrementing by 1. Now if I was to increment this by, let's say, 2, I could say plus equals 2. That will reduce the number of times this particular line is printed. Let's hit the play button, and notice that 99 now is being printed only 5 times. And notice the value of j, 0, 2, 4, 6, 8. All right, so in a nutshell, this loop is running for every iteration of the outer loop. And since the outer loop goes from 0 to 99 for each one of those numbers, this thing is going to run. It runs based on its own instructions, right? I can change this value to 100 now, and increment this by 1 every iteration, now take a look at what happens. We're going to be printing a lot more values, right? The value of IDX was 99. It started from J's value being 0 all the way up to 99. So it printed basically 100 times 100, which is 10,000. There's basically 10,000 lines here. Now we can get really crazy and put in another loop inside of this nested loop, but that's really going to, you can take a guess, really slow down your program. Let's try that. Let me show you what's going to happen here. For int, and I'll say i's, we haven't used the I variable yet, and we can say I is less than 100, and we can say I plus plus, and now I'll include the ith variable here as well. All right, now hit the play button and notice that it's still running. It's significantly slower, right? My program has not ended yet. And the reason for that is this particular loop is running 100 times for every value of j, and this j is running, this particular loop right here is running 100 times for every iteration of its enclosing loop, which is the outermost loop. So things can get really hairy and really slow. I'm just going to continue to make this as crazy as possible. So let's say the initial value of x is 0, and as long as x is less than 100, this inner loop is going to run, and we will increment the value of x by 1 every iteration. And I will wrap this statement here, and then inside of here, let's also add the value of x. Now, I don't expect this program to finish anytime soon, all right? Let's hit the play button, and we're going to go on for a long time. So when you're writing computer programs, you want to make sure you stay away from this nested looping, right? At max, you want 2 loops. But even that could be ridiculously slow depending on the amount of data you have. Let's say the outer loop has, for example, 10 iterations, and the inner loop has 10 iterations. So 10 times 10 is 100. That's 100 total iterations, and the program is over. Not too bad. But let's say if the outer loop had 100 and the inner loop also had 100 iterations, so that's 100 times 100, we're already at 10,000. So let's explore what happens. I'm going to get rid of these 2 inner loops. Right now we have, if you look at it from the inside out, we have a loop inside of a loop that's inside of a loop that is inside of a loop, okay? So I'm going to get rid of this, these 2 loops here, these inner loops. Let's get rid of those. And I want to get rid of these 2 brackets just so they line up. And right now the indentation is all screwed up, so you can press the Command, Shift, and F key, and that will sort of line up the brackets there. And since I and X, these variables don't exist anymore, let me just get rid of those. And now we are just left with 2 loops, a loop inside of a loop. So oftentimes it's easier to think about nested loops by looking from inside out. And what that means is we look at the innermost loop, which is this guy right here, and we see that this line is going to be printed 100 times. But since this entire block of code is wrapped in another loop that will cause execution for 100 times, then you have 100 times 100. That's 10,000 times you'll actually see this sentence. So if we put a counter out here, let's say we define a variable of type int, we'll call it counter, and we will initialize its value to 0. And inside of here, we can increment the value of counter. And then right outside of this loop here, once this program is about to be over, we can print out the value of counter. Like that. Hit the play button and notice that it did print 10,000 times. Now if I up that to 1,000 and I make this 1,000 as well, that's 1,000 times 1,000, that's 1,000,000. So hit the play button and notice that it really slows down your program. Technically, it's not really slowing down your program per se, but it's just taking your program much longer to complete because of the sheer number of instructions that it has to execute. So let's say if you had 10 iterations inside of 10 iterations, that's only 10 times 10, 100 instructions that the computer has to execute. That's not a big deal. But let's say you had 1,000 data points, and for every one of those data points, we had to do some looping. And if we had these nested loops like this, that would really slow down your program. 1,000 times 1,000, that's 1,000,000 instructions that the computer has to run. So obviously it will take much longer than just 100 instructions. And if you bump that up to, for example, 1,000,000 iterations inside of 1,000,000 iterations, that's a lot of instructions the computer has to work on, and that will take forever. So it really comes down to the question, is this program scalable or not, right? It may work great with just 10 or 15 data points, but how significantly slower does it get when you give it 50 or 100 or 1,000 data points? If it gets significantly slower the more data you give it, then that means it will have big scalability issues. And oftentimes you can be certain that, hey, this piece of code is only going to see 5 or 6 data points, so it's not really a sticking point, but you never know how much more data your program will get over time. So it's best to try to avoid nested loops when possible. There are problems out there that just require you to use nested loops. There's really no way around it in certain cases. And for those things, you can maybe reduce the number of iterations. Look for ways in being able to reduce the number of iterations by using conditions that if this is true, then you don't have to continue running this loop. We looked at the break statement. And oftentimes you can break out of a loop prematurely because a particular condition has been met, and you don't have to run all of those instructions that are still pending. So in this lesson, I just wanted to introduce to you that inside of a loop, you can have any bit of code, including another loop.